Linear equations in one variable. Caroline is a full-time college student planning a spring break vacation. To earn enough money for the trip, she has taken a part-time job at the local bank that pays $15 an hour, and she opened a savings account with an initial deposit of $400 on January 15th. She arranged for a direct deposit of her payroll checks. If spring break begins March 20th and the trip will cost approximately $2,500, how many hours will she have to work to earn enough money to pay for her vacation? If she can only work 4 hours per day, how many days per week will she have to work? How many weeks will it take? In this section, we will investigate problems like this and others which generate graphs like the line in Figure 1. Solving linear equations in one variable. A linear equation is an equation of a straight line, written in one variable. The only power of the variable is 1. Linear equations in one variable may take the form ax plus b equals 0 and are solved using basic algebraic operations. We begin by classifying linear equations in one variable as one of 3 types: identity, conditional, or inconsistent. An identity equation is true for all values of the variable. Here is an example of an identity equation. 3x equals 2x plus x. The solution set consists of all values that make the equation true. For this equation, the solution set is all real numbers because any real number substituted for x will make the equation true. A conditional equation is true for only some values of the variable. For example, if we are to solve the equation 5x plus 2 equals 3x minus 6, we have the following. 5x plus 2 equals 3x minus 6, 2x equals negative 8, x equals negative 4. The solution set consists of one number, negative 4. It is the only solution, and therefore we have solved a conditional equation. An inconsistent equation results in a false statement. For example, if we are to solve 5x minus 15 equals 5 times x minus 4, we have the following. 5x minus 15 equals 5x minus 20, and negative 15 is not equal to negative 20. It's a false statement. Indeed, negative 15 does not equal negative 20. There is no solution because this is an inconsistent equation. Solving linear equations is one variable, and one variable involves the fundamental properties of equality and basic algebraic operations. A brief review of those operations follows. Linear equation in one variable. A linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. How to? Given a linear equation in one variable, use algebra to solve it. The following steps are used to manipulate an equation and isolate the unknown variable so that the last line reads x equals. If x is the unknown, there is no set order, and as the steps used depend on what is given. 1. We may add, subtract, multiply, or divide an equation by a number or an expression as long as we do the same thing to both sides of the equal sign. Note that we cannot divide by 0. 2. Apply the distributive property as needed. A multiplied by b plus c equals ab plus ac. 3. Isolate the variable on one side of the equation. And 4. When the variable is multiplied by a coefficient in the final stage, multiply both sides of the equation by the reciprocal of the coefficient. Example 1. Solving an equation in one variable. Solve the following equation. 2x plus 7 equals 19. Solution. This equation can be written in the form ax plus b equals 0. By subtracting 19 from both sides, however, we may proceed to solve the equation in its original form by performing algebraic operations. 2x plus 7 equals 19, x equals 6. Subtract 7 from both sides and multiply both sides by half or divide by 2. Example 2. Solving an equation algebraically when the variable appears on both sides. Solve the following equation. 4 multiplied by x minus 3 plus 12 equals 15 minus 5 multiplied by x plus 6. Apply standard algebraic properties. 4 multiplied by x minus 3 plus 12 equals 15 minus 5 multiplied by x plus 6. Apply the distributive property. Combine like terms. Place x terms on one side and simplify, and multiply both sides by 1/9, the reciprocal of 9. Analysis. This problem requires the distributive property to be applied twice, and then the properties of algebra are used to reach the final line, x equals negative 5/3. Solving a rational equation. In this section, we look at rational equations that, after some manipulation, result in a linear equation. If an equation contains at least one rational expression, it is considered a rational equation. Recall that a rational number is the ratio of two numbers, such as 2/3 or 7/2. A rational expression is the ratio or quotient of two polynomials. Here are 3 examples. X plus 1 divided by x squared minus 4, 1 divided by x minus 3, or 4 over x squared plus x minus 2. Rational equations have a variable in the denominator in at least one of the terms, and our goal is to perform algebraic operations so that the variables appear in the numerator. In fact, we will eliminate all denominators by multiplying both sides of the equation by the least common denominator, LCD. Finding the LCD is identifying an expression that contains the highest power of all the factors in all of the denominators. We do this because when the equation is multiplied by the LCD, the common factors in the LCD and in each denominator will equal 1 and will cancel out. Example 3. Solving a rational equation. Solve the rational equation. 7 over 2x minus 5 over 3x equals 22 divided by 3. Solution. We have 3 denominators, 2x, 3x, and 3. The LCD must contain 2x, 3x, and 3. An LCD of 6x contains all 3 denominators. In other words, each denominator can be divided evenly into the LCD. Next, multiply both sides of the equation by the LCD, 6x. 6x multiplied by 7/2 x minus 5/3 x equals 22 over 3 multiplied by 6x. Use the distributive property. Cancel out the common factors. Multiply remaining factors by each numerator. 1/4 equals x. A common mistake made when solving rational equations involves finding the LCD when one of the denominators is a binomial. 2 terms added or subtracted, such as x plus 1. Always consider a binomial as an individual factor. The terms cannot be separated. For example, suppose a problem has 3 terms and the denominators are x, x minus 1, and 3x minus 3. First, factor all denominators. We then have x, x minus 1, and 3 multiplied by x minus 1 as the denominators. Note the parentheses placed around the second denominator. Only the last 2 denominators have a common factor of x minus 1. The x in the first denominator is separate from the x in the x minus 1 denominators. An effective way to remember this is to write the first denominator in separate. An effective way to remember this is to write the factored and binomial denominators in parentheses and consider each parentheses as a separate unit or a separate factor. The LCD in this instance is found by multiplying together the x, one factor of x minus 1, and the 3. Thus, the LCD is the following. X multiplied by x minus 1 multiplied by 3 equals 3x multiplied by x minus 1. So both sides of the equation would be multiplied by 3x multiplied by x minus 1. Leave the LCD in factored form, as this makes it easier to see how each denominator in the problem cancels out. Another example is a problem with 2 denominators such as x and x squared plus 2x. Once the second denominator is factored as x squared plus 2x equals x multiplied by x plus 2, there is a common factor of x in both denominators, and the LCD is x multiplied by x plus 2. Sometimes we have a rational equation in the form of a proportion, that is, when one fraction equals another fraction and there are no other terms in the equation. A over b equals c over d. We can use another method of solving the equation without finding the LCD, cross multiplication. We multiply terms by crossing over the equal sign. So if A over B equals C over D, then A over B equals C over D, but you can cross multiply. Multiply A and D and B and C, which results in AD equals BC. Any solution that makes a denominator in the original expression equal 0 must be excluded from the possibilities. Rational equations. A rational equation contains at least one rational expression where the variable appears in at least one of the denominators. How to? Given a rational equation, solve it. 1. Factor all denominators in the equation. 2. Find and exclude values that set each denominator equal to 0. 3. Find the LCD. 4. Multiply the whole equation by the LCD. If the LCD is correct, there will be no denominators left. 5. Solve the remaining equation. 6. Make sure to check solutions back in the original equations to avoid a solution producing 0 in a denominator. Example 4. Solving a rational equation without factoring. Solve the following rational equation. 2 over x minus 3 halves equals 7 over 2 over x. We have three denominators, x, 2, and 2x. No factoring is required. The product of the first two denominators is equal to the third denominator, so the LCD is 2x. Only one value is excluded from a solution set, 0. Next, multiply the whole equation, both sides of the equal sign, by 2x. 2x multiplied by 2 divided by x minus 3 halves equals 7 over 2x multiplied by 2x. Distribute the 2x. Denominators cancel out. X equals negative 1. The proposed solution is negative 1, which is not an excluded value, so the solution set contains one number, negative 1, or negative 1, written in set notation. Example 5. Solving a rational equation by factoring the denominator. Solve the following rational equation. 1 over x equals 1/10 minus 3 divided by 4x. Solution. First, find the common denominator. The three denominators in factored form are x, 10 equals 2 multiplied by 5, and 4x equals 2 multiplied by 2 multiplied by x. The smallest expression that is divisible by each one of the denominators is 20x. Only x equals 0 is an excluded value. Multiply the whole equation by 20x. 20x multiplied by 1 over x equals 1/10 minus 3/4 x multiplied by 20x. 35 over 2 equals x. The solution is 35 over 2. Example 6. Solving rational equations with the binomial in the denominator. Solve the following rational equations and state the excluded values. A, 3 over x minus 6 equals 5 over x. The denominators x and x minus 6 have nothing in common, therefore the LCD is the product of x multiplied by x minus 6. However, for this problem, we can cross multiply. 3 over x minus 6 equals 5 divided by x equals 15. The solution is 15. The excluded values are 6 and 0. B, x divided by x minus 3 over equals 5 over x minus 3 minus half. The LCD is 2 multiplied by x minus 3. Multiply both sides of the equation by 2 multiplied by x minus 3. 3x equals 13, x equals 13 divided by 3. The solution is 13 divided by 3. The excluded value is 3. C, x over x minus 2 equals 5 over x minus 2 minus half. The least common denominator is 2 multiplied by x minus 2. Multiply both sides of the equation by x multiplied by x minus 2. 2 multiplied by x minus 2 multiplied by x over x minus 2 equals 5 over x minus 2 minus half multiplied by 2 multiplied by x minus 2. 2x equals 10 minus x minus 2. 2x equals 12 minus x. 3x equals 12. And x equals 4. The solution is 4. The excluded value is 2. Example 7. Solving a rational equation with factor denominators and stating excluded values. Solve the rational equation after factoring the denominators. 2 divided by x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. State the excluded values. Solution. We must factor the denominator, x squared minus 1. We recognize this as the difference of squares and factor it as x minus 1 multiplied by x plus 1. Thus, the LCD that contains each denominator is x minus 1 multiplied by x plus 1, and multiply the whole equation by the LCD, cancel out the denominators, and solve the remaining equations. Distribute the negative sign, and remember that negative 3 equals x. The solution is negative 3. The excluded values are 1 and negative 1. Finding a linear equation. Perhaps the most familiar form of a linear equation is the slope-intercept form, written as y equals mx plus b, where m equals slope and b equals y-intercept. Let us begin with the slope. The slope of a line refers to the ratio of the vertical change in y over the horizontal change in x between any 2 points on a line. It indicates the direction in which a line slants as well as its steepness. Slope is sometimes described as rise over run. M equals the change in our y point values over the change in our x point values. M equals y2 minus y1 divided by x2 minus x1. If the slope is positive, the line slants to the right. If the slope is negative, the line slants to the left. As the slope increases, the line becomes steeper, and some examples are shown in figure 2. The lines indicate the following slopes: m equals negative 3, m equals 2, and m equals 1/3. The slope of a line. The slope of a line m represents the change in y over the change in x. Given 2 points, x1, y1, and x2, y2, the following formula determines the slope of a line containing these points. M equals y2 minus y1 all over x2 minus x1. Example 8, finding the slope of a line given 2 points. Find the slope of a line that passes through the points 2, negative 1, and negative 5 and 3. We substitute the y values and the x values into the formula. M equals y2 minus y1 all over x2 minus x1. M equals 3 minus negative 1 all over negative 5 minus 2 equals negative 4/7. The slope is negative 4/7. Analysis. It does not matter which point is called x1, y1, or x2, y2. As long as we are consistent with the order of the y terms and the order of the x terms in the numerator and denominator, the calculation will yield the same result. Point-slope formula. Given the slope in 1 point on a line, we can find the equation of the line using the point-slope formula. Y minus y1 equals m multiplied by x minus x1. This is an important formula as it will be used in other areas of college algebra and often in calculus to find the equation of a tangent line. We need only 1 point in the slope of the line to use the formula. After substituting the slope and the coordinates of 1 point into the formula, we simplify it and write it in the slope-intercept form. The point-slope formula. Given 1 point in the slope, the point-slope formula will lead to the equation of a line. Y minus y1 equals m multiplied by x minus x1. Standard form of a line. Another way that we can represent the equation of a line is in standard form. Standard form is given as ax plus by equals c, where a, b, and c are integers. The x and y terms are on one side of the equal sign, and the constant term is on the other side.